Spravíš co? Stačí asi, keď povieš, že ďalšia prednáška ja nás predstavím.
Jo.
Tak to môžem teda použiť?
Tak to můžete, ale teďka už je... Jo, tohle je normálně zapnutý.
To môžeš dať im a ja si zoberiem toto.
Dobře.
Pala. Chcete aj vy toto?
Nechám nasať a potom tady jenom to přepne a to odplníš, tak je to zpomeň.
Počkaj. Že si mohol nahadiť.
Tady to potom budeš mít možná mítnutý.
Jo, už som hodil.
Alright folks, let's start with the new presentation optimizing DNF metadata given by a team of speakers.
Can you hear me? Hey, now. Okay. So hello, my name is Michal Luščan, and together with Pavel Vichan and Lukáš Slovka, we will present you our research project, which is a LabQ research project. LabQ, it's a joint initiative of Red Hat and the Faculty of Information Technologies. So big thanks belongs to both organizations. And as for the agenda, I will tell you something about the current state and the motivation. And also I will try to briefly explain how ZSync works. Then Pavel will show you some quick demo of our prototype of plugin. And Lukáš will tell you something about gathered data during our research. So at the end of the presentation, you will see the roadmap of our project. So metadata and DNF. Metadata files contains data about packages, files, and groups. They are essential for resolving in DNF, and the size of them is approximately tens of megabytes, and they are compressed in gzip format. This applies for Fedora, and the problem is that they are constantly changing with package updates and so on. So DNF use metadata to resolve dependencies of packages, install groups, or mostly for anything you need fresh metadata in DNF. So the motivation for our project and our goals are following. So the current state in DNF is that the DNF re-downloads whole metadata files again with every subtle change in them. So this is, politely speaking, not optimal. So our project goal is then, of course, minimization of metadata download size, and we hope we will improve user experience of DNF and also reduce load on Fedora mirrors. So that was our project goals, and now the quick introduction to ZSync. Please don't take it too seriously. Things are, of course, more complicated. And so ZSync is a generic tool for synchronization of files. It works on binary level, and the comparison of files is based on checksum of blocks. So, of course, everything has its advantages and disadvantages. So most notable advantages of ZSync are following. It does not require any special server-side service, and it's very easy to fall back to regular downloading. If something bad happened during the ZSync download, you will just download the usual way. So it's also compatible with older package manager, which does not know anything about ZSync and so on. So, and of course, disadvantages. It requires special ZSync files to be presented on the server side. Those ZSync files contains pre-computed checksums of blocks of the file you want to download. Also, there is one drawback, and that it's that compressed files that Z-Sync does not work well with compressed files, and they have to be crafted in a special way, mostly with rsync cable option for gzip, for example. And sometimes it's quite buggy, of course, as every software on the planet Earth. So now I will tell you something. I will try to explain you how Z-Sync works on the simple example. I promise I won't be drawing anything in the next 10 years because these are very naive pictures and I'm author of them. So imagine a situation. You have a server with the updated version of some file, and you as a client has older version of the same file. So in case of Z-Sync, there is also a Z-Sync file presented on the server. As I said, it contains pre-computed checksums of blocks. So first of all, if you want to synchronize something by Z-Sync, Z-Sync downloads the Z-Sync file. This is the first download in the process. Now it will, on the client side, it compares the changed blocks on the files and identifies them. And the second download is issued via HTTP range request. HTTP range is a feature of HTTP 1.1. So the server has to support HTTP 1.1 protocol. And via HTTP range request, you can download only certain blocks of the file. You don't have to download the whole file. You can specify only certain blocks, as I said. So, and the last step of the Z-Sync is, of course, the reconstruction of the file on the client. So this was a very brief introduction to Z-Sync. And Pavel will tell you something about our implementation, and he will also show you some short demo of implemented Z-Sync prototype plugin in DNF.
So my name is Pavel Vicen, and I tell you about our implementation. Our implementation consists of two parts, client side and server side. At the client sides, we implemented DNF passive plugin. It synchronized metadata before actual DNF commands. It calls Z-Sync binary to reduce dow landing sites. And the server side, we use HTTP server. We implemented bash script which periodically checkouts new updates. If updates are available, we backed old metadata files at the server and download new metadata files. The gzip files had to repacked with rsync cable option. Thanks. And when the change the gzip files, the change checksum, and we had to change checksum in repomd.xml. And last step, create Z-Sync file. So I showed quick demo. So I have old metadata files. I show checksum these files. And for example, I want to find out version of YouTube DL package. From the cache, I used the DNF repo query command. This version is now there, and I now update metadata via DNF make cache. It takes several seconds because it is activated our plugin which download these metadata files, and I can enter again DNF repo query command and show the new version of this package. And finally, I show new checksum of these files because it is downloaded successfully. That is all, and Lukáš tell you about the results we measured.
Yeah, thank you. Okay, so hello everyone. My name is Lukáš. Thanks. And I will be talking about results that we gathered. But before I get to it, I would like to talk a bit more about the actual drawbacks of this approach. So the obvious drawback is on the server side, we have to generate zsync files for each of metadata file, and also we have to repack them with rsync cable. So in this graph, the first bar named old shows the data as there on the servers now. We have just the metadata archives. Of course, there are more files, but the files and primary are the heavy hitters. They are the largest of the files, and others are considerably smaller. So for the clarity of the presentation, we work only with these two. So we can see that the files are slightly smaller in the size than in our proposed solution, and that's due to the rsync cable flag, which basically makes the compression method slightly worse, but it's nothing too serious. The increase in size is only by 3 to 5%. Zsync files are slightly larger. Generally, on average, it's by 8 to 10% increase in size. So all in all, it's approximately 15%. And let's remember that we are talking about tens of megabytes, so the servers can handle it pretty easily. So the drawback is not that large. Well, how about the gains? So in this graph, we have plotted increase of synchronization size, which is basically the data you download, and to the synchronization frequency. And by synchronization frequency, we mean the time span between the updates of the system, between the last download of metadata. So, for example, in this graph, we can see that if we were to update our metadata, let's say, once per week, we would only have to download 3 megabytes as opposed to downloading whole 15 to 20 megabytes of entire metadata on the server. So the download size is greatly reduced, which is a very positive result. Well, the graph also shows pretty much the steady increase of metadata download size. Per additional day, it's approximately 200 up to 250 kilobytes, which is not that much. And by this rate, the download size with zsync would reach the download size as it is now in approximately 3 to 4 months, which is nowhere near the usual use case, because people usually update their system a few times per week. So we are in this area of the graph, and we can see that it's really efficient. Okay, so that would be for the results, and it's really encouraging. timeline of the project. We've been working on it for several months, mostly gathering data. The graphs that were shown were for Fedora 25, pretty much since its release in late November. And currently we are in the phase of discussing this with Fedora community, which is pretty much what we are doing here. And we are looking forward to integrating it to DNF. So if you have any questions, please feel free to ask. Yes?
As far as I know, ZSync is not yet packaged in Fedora, and there were some issues like it was bundling a part of rsync in itself, so it was not an easy package to take into Fedora. Have you looked into that? Or
Yeah, of course, but now we are allowed to bundle that part of ZSync in Fedora packages, as far as I know, so it should be no problem.
Great.
Yeah.
Yeah, thank you.
Your work seems to be targeting work on compressed files, but the files itself are XML text files. So why do you go to work into the work with passing diffs on binary basis when you can just do a diff on text basis? Because you can basically switch to Git, because the Git is what you can like use to update the files between one version and two version and third version.
Yeah.
Well, why you stay with the binary format and you don't work with the text format?
Yeah, the question was about. The question was about the some proposal to use text files instead of gzip files. We decided for this approach because we wanted to be backward compatible with the previous package managers, and that's the answer.
So that's the only thing you consider that.
Yeah, we don't want to break anything.
Question: did you consider using edif, packaged it as Debian used it for 4 years, which produce diffs according differences from each day?
Yeah, the question is whether we considered some Debian style. No, we haven't. We can talk about it after this presentation. So, no more questions? Yeah?
Have you actually done any timing comparisons of things like container builds where you need to update the cache, where currently the time required to download 10 megabytes of stuff?
It heavily depends on your bandwidth, the speed of your connection.
Yeah.
So, sorry, the question was whether we measured the time of actual downloading. So, questions? Yeah.
My question is, like, HTTP can compress the data, isn't like wasting of some resources, like compress it on the server, then send it via HTTP, when HTTP can compress it by itself. So, by actually sending gzip files.
Yeah, the question was whether we are not wasting the bandwidth of HTTP request because HTTP can.
Basically, you can probably send the text data or something like that, which you can more easily like do just the differences or something like this. Just send the part of the data and do the HTTP compression.
Yeah, as I said, we want to be as much compatible as we can. So we don't want to change this on the Fedora infrastructure side. Yeah.
Is your approach compatible with the security feature of metadata or YAM repositories?
Which
Signing.
yeah, we can use this mic for questions, I think.
My question is, can you use your approach with the YAM security feature, that means the signing of repository?
Of course, because these data are produced by Fedora infrastructure, so they can sign the files.
Yeah, but that thing can handle that.
We will do integration, so we will consider this, of course.
So I have just a small remark because regarding your statistics. That looks very promising, but it's not answering the right question. The right question is how much does the overall download size of a Fedora lifecycle goes down, depending on how often you update. The thing is, the metadata of the updates repository, which is what we are talking about, grows over time linearly. And if you download it every time, you basically need squared the time at the space as a download amount. And of course, it would be interesting to actually point out that with your method, you can get it down to a linear thing with a small overhead. And so I think you can make your case even much, much better. Mm-hmm. So I encourage you to
actually, we have all data gathered, so we can do any computation.
I'm very optimistic that you can make a even much better case for your approach.
Thank you for your question.
I can answer the problem with the security because I think that this is about signed metadata, and because you when you download via the zsync method, you get the same metadata as you have on the server, so you can verify the checksums or verify the signatures anyway. So there is no problem with this. There is only the thing that you have to verify the checksums after you do the zsync. Yeah, but there's even the zsync files don't have to be signed because these are only intermediates and they don't affect. If you at the end of the zsync verify the signatures, then you are okay.
Yeah, thank you for the clarification. And probably the last one question.
So you mentioned in your presentation that sometimes zsync is buggy. Like what exactly the problems are, and is a problem that zsync upstream looks dead? Is it a problem for you?
Yeah, mostly this is the case. And as for the issues,
sometimes zsync cycles when Dolant %, and print message %, Dolant, and cycle non-stop.
Yeah, thank you. Have a nice day.
Já jsem včera